Welcome to part 2 of exponential functions, and this is going to focus on applications of exponential functions, especially involving money. So the most common application when you hear of an exponential function is how much money I will have in an investment. So most banking and investments that are done right now have the type of interest that's called compound interest, and that means that I get money both on what's on my investment on the first month, and then the next month I get it on my investment and the interest, and it builds on itself and it compounds. That's what that's referring to. The compound interest formula looks like this. Okay, so when we have these different letters, A is representing the final amount, P is the principal investment, or the initial investment. R is the interest rate as a decimal. T is time in years. And N, these two N's, there's two of them, is the number of times compounded in 1 year. Now, you may see that things are compounded yearly. You might see, or sometimes called annually. Sometimes you'd see semi-annually, that's twice a year, quarterly, 4 times a year. The most common in the real world is monthly, and that's like credit cards are compounded monthly, and most bank investments are compounded. So we're going to look at, so let's invest $1,000. Whoops, missed the dollar sign. At 6% annual interest, because apparently we've turned back the clock to the late 80s, early 90s. And we're going to find out how much money I'll have in 10 years. So the way this will work, so in all of these, P is 1,000, R is 0.06, T is 10, and this one, N is 1. So I'm going to have so there's my key, 1,000, 1 plus 0.06 over 2 to, over 1. I'm thinking about the next one already, to the 10th. So it's really just 1,000, 1.06 to the 10th. So 1,000, 1.06 to the 10th. So $1,790.85. Now, this is making an assumption, one, that I have a place where I found 6% interest, which good luck with that right now, but also that I made no additional deposits or withdrawals from this account. So this is very similar to what's called a certificate of deposit, or CD, where you've put your money in, and sometimes you get a little bit higher interest rate because you're just leaving your money in the bank at that place. So semi-annually, all the same for PR and T, but now my N is 2. So we'll have 1,000, 1 plus the 0.06 over 2 to the 2 times 10, or 20. So what this happens is, because the annual interest rate, or APR, that's what sometimes this is written as, you'll see APR as a phrase. They're not going to give me 6% every time they compound. I want 6% over the whole year. So they'll give me 3% each of those 2 times. Okay, so now I'm going to have 1,000, 1.03 to the 20th on $1,806.11. So dollar signs go in front. Round into 2 decimal places, because don't chip me out of my 11 cents. And you can see I made a little bit more money. A little over $15 more, just by compounding it more frequently. So now quarterly, I'll make my N4. So this I could also do this in a couple steps and do 0.06 over 4 if I didn't want to do in one line like that. And then raise that to the 40th and then multiply by 1,000. Oops, extra one. So $1,814.02. So go try it and try monthly, which will be N is 12, and daily, which we'll use 365. Some banks, if they're going to do daily, actually use 360. So go ahead and try those two. Pause the video. Okay. So hopefully you got a chance to try those two. Those are the answers for the last two. So what's happening as we compound more frequently? You can see I have an increase on each of them, but notice the biggest jump is from 1 to 2. And I look at between monthly and daily, there's only a couple dollar difference. Not significant. It's almost as if they're approaching something. Dun dun dun. Like they're approaching something called compounding continuously. And that brings me to the number E. So if I wanted to, okay, do a little investigation. So this is a paddle left. Let's see. We're going to do plus 1 over x to the x. I know, it's kind of a weird thing. I look at the table. Sorry, changing my settings around because I didn't do it ahead of time. Why would I have had it set correctly? Nope. So when I make it 1, it's 2. When I look at 10, 2.59. If I look at 100, oh, not a big change at all. Even smaller. Let's put a lot of zeros in. Look at that. Barely any change at all. What this is approaching is the number E, or Euler's constant. It's another irrational constant. It comes up a lot in calculus and all sorts of stuff with logarithms. It's kind of cool. But I call it like pi's younger brother because it's a little bit smaller and less well known, but just as important. So there's E. You can find the E by hitting second and the divide sign. See, it looks at this point like there's a pattern, but there isn't if you go further out. So E, if I want to raise it to the 4th, is 54.598. 4.598. The other spot the E is if you hit second ln. It gives you e to the power, and you can do e to the 10th like that. And I'm just going to do that because I don't want to write it out. Okay. So when money is being compounded continuously, we use the formula A equals P E to the RT. A very pertinent formula. Get it? Get it? Our interest rate's the same, still as a decimal. And notice it's not 1 plus R. It's just R. Okay? And then this is my time, and then my initial and ending of it. So let's do that same $1,000 at 6% interest, compounded continuously now. We'll have 1,000 e to the 0.06, and we're still doing 10 years. We'll say 10 years. Okay? And so let's see what this comes out as. If I compound continuously, and we'll compare with how much we made if we compounded daily. E to the 0.06 times 10. Survey says, oh, like not big change at all. $1,822.12. So comparing, I made 9 more cents by compounding continuously. And that concludes the lesson on 5.4.